All right. Hi, Math 8 students. We are going to do a recording here for our next test coming up, which is going to be on April the 19th. That's a week from the Tuesday you get back after the break. And it's going to be on lessons 24 to 28. So we're going to go over a lot of questions here. And first, let's do a little cartoon to kick it off. This guy just has crashed himself into his Dell computer and he says, "Tech support, I'd like to report a farmer in the Dell." I don't know if you guys know that little song, "Farmer in the Dell." Anyways, it makes sense, a little more sense if you do know that little nursery rhyme or whatever you call it. So let's get right into this stuff then. All right, so we're going to talk about solving equations. We're going to review solving equations. And remember that equations are just like a scale. And if you look at a scale, remember it's in balance. Remember that with an equation, the left side of the equation needs to equal the right side of the equation. And so when we look at the scale here, we can see that we have 3 plus 2 on the one side. We have 5 on the other side. So again, both sides are equal. And when we solve an equation, that's always our goal, is to get the left side of the equation, which is going to be some variable. It could be x, could be y, could be a. And we're going to set that equal to some number. And when we're done that, when we've got something like x equals 5 or b equals 28, then we're done. So that's the goal in solving any equation. And the steps we're going to use in solving the equation are going to be steps to reach that final goal. Okay, so first of all, we're going to look at what we call one-step equations. So like the name suggests, we only need to carry out one step to solve these equations. So here's some examples of one-step equations. You can see why they're called one-step equations when you look at them. So again, in each step, we only need to solve using one step, and we're going to always use the opposite math operation to the one that's shown in the equation to solve it. So again, just a review of what opposite math operations are. Plus and minus are opposite math operations, and so are divided and times. Okay, so here's an example of an equation that has addition in it, and so we're going to use the opposite of addition, which is subtraction, to solve this. So since we have x plus 5, we're going to subtract 5, and again, we always need to do it to both sides of the equation. So when we have 5 and minus 5, we just end up with x on the left side, and 10 minus 5 gives us 5 on the right side. So looking at the next one then is a situation where we have multiplication. Again, remember 5a means 5 times a, so we're going to solve it by dividing. So we divide both sides by 5, because we want to get rid of the 5 that's with the a. So 5a over 5. The 5 and the 5 cross off, and we just end up with a. 10 divided by 5 is 2, so a equals 2. All right, so here's a situation where we have dividing by 5, and so we need to solve it by doing the opposite of dividing by 5, which is multiplying by 5. So we multiply both sides by 5, and we have 5 on top, 5 on bottom, so we're left with just a on the left side, and 5 times 10 is 50. A equals 50. All right, so the good thing about equations is that we can always check our answer, and we check by seeing if the left side of the equation equals the right side. So that's a real bonus, and I want to encourage you guys, every single time you solve an equation, check to see if the left side equals the right side by plugging your answer back into the original equation. So if the answer we got was 5, we put 5 in for x, and that gives us now 5 plus 5 on the left side. We have 10 on the right side. So since 10 equals 10, we know we did it right. So we always say, since left side equals right side, the answer is correct. Again, check every one of your answers using that method. I won't be checking all the answers here. It's just going to take too much time. But I just want to encourage you guys to do that. Okay, so you're going to see in the whiteboard session here that the purple questions are ones that you guys can practice later on. And again, I encourage you to do this. If you can do each one of these on your own and you can get the answers, you should be able to do very, very well in the test. So again, if you have any problems with any after you watch the recording, please ask me. But what I'd encourage you to do is to watch the recording and start it and stop it as much as you need to, just to make sure you're focusing on what the recording is going over. Okay, so we got our one-step equation here. So I want to ask you guys then, if you focus on the blue text, it says, what do we need to do to both sides of the equation in order to solve this? So think about, what do we need to get rid of? Okay, we need to get rid of anything that's being added or subtracted to the variable term, or x. So how are we going to do that? So we need to get rid of the minus 7 that's with the x, and we do that by adding 7 to both sides of the equation. So when we have minus 7 plus 7, we end up with x on the left side. 14 plus 7 is 21 on the right side. Okay, next question. What do you think we need to do to both sides of the equation to get rid of the 6 here? So we have 6 times a. So what do you think we need to do? Since we're multiplying by 6, we need to divide both sides by 6. 6a over 6 gives us a on the left. 18 over 6 gives us 3 on the right. Okay, how about this next one? What do you think we need to do to both sides? Again, remember, a over 4 really means a divided by 4. So what's the opposite of a divided by 4? That's going to be times 4. So we multiply both sides of the equation times 4. The 4's cancel out, and we're left with just a on the left. 4 times 16 gives us 64 on the right. Okay, now two-step equations are going to require two math operations to solve them. And some examples of two-step equations are this one and this one. So as you can imagine, the solution to any two-step equation is to use two opposite math operations to the ones that are found in the equation. Okay, so for this one here, we're going to use division and then subtraction to solve it. And that's because we have multiplication, first of all, and we have addition. So our first step is we always need to get rid of any numbers that are either added or subtracted to the variable term. Okay, this is called the variable term, 3x, because it contains the variable x. So anything that's either added or subtracted to it, we need to get rid of first. So since we have plus 2 being added to it, we need to get rid of the plus 2. So we do that by subtracting 2 from both sides of the equation. You can see that the 2's cancel out, 2 and minus 2, we're left with 3x, and on the right side we're left with 9. So we have 3x equals 9 at this point. The next thing we need to do, as you can imagine, since we have 3 times x, you do the opposite of 3 times, which is divided by 3. So we divide both sides by 3. And then we're left with just x on the left and 3 on the right. Okay, so again, remember, focusing on the equation, the first thing we always want to do is get rid of anything that's either added or subtracted from the variable term. That's step 1. Then we deal with the 3x and get rid of the 3. Okay, so for this one here, we're going to use multiplication and addition to solve it. And why is that? Because first of all, we have division and we also have subtraction. So we're going to do the opposite of those two operations. So again, first we get rid of the minus 5 by adding 5 to both sides of the equation. And when we do that, we're left with just the a over 4 on the left side, and we have 10 on the right side. So now we need to get rid of that divided by 4, so we're going to multiply both sides of the equation by 4. And you can see the 4's are going to cancel out and leave us with a on the left. 4 times 10 is going to give us 40 on the right. And again, I'm going to show you how to check our answer for this one here. The original equation is a over 4 minus 5 equals 5. We're going to plug in our answer 40. So instead of having a, we have 40. 40 over 4 is going to give us 10. 10 minus 5 on the left, that's going to equal 5. And the right side already equals 5. So since 5 equals 5, left side equals right side, the answer is correct. Okay, let's try our hand now. It's two of these, or some of these two-step multiplication questions. So here's one right here. Again, practice all the purple questions. So looking at this one here, what do you think we're going to need to get rid of first? Are we going to get rid of the 4 that's with the b? Or are we going to get rid of that minus 3? And once you decide that, what step are we going to use to get rid of that? Okay, so the answer, we always get rid of any numbers that are added or subtracted from the variable terms. So we're going to get rid of this minus 3. And what do we do to do that? We're going to add 3 to both sides of the equation. So you can see here we get rid of that minus 3 by adding 3 to both sides. We end up with 4b on the left. We end up with 16 on the right. So based on what we have now with our equation, what are we going to need to get rid of? And what are we going to do to get rid of it? So since we have 4b, which is 4 times b, we do the opposite of 4 times, which is divided by 4. We end up with b on the left. 16 divided by 4 gives us 4 on the right. Okay, here's another two-step equation. What do we need to get rid of first? And what steps are we going to use to get rid of it? So once again, we need to get rid of any number added or subtracted to the variable term. So we get rid of the plus 4. How do we get rid of it? Subtracting 4 from both sides. So you can see that here. We're subtracting 4 from both sides. We end up with c over 3 on the left side. When we do the math, we end up with 2 on the right. So what are we going to get rid of now on the left side? And how do we get rid of it? Well, since we have c over 3, to get rid of c divided by 3, we multiply both sides by 3. The 3's cancel out and leave us with c on the left. 3 times 2 is 6 on the right. Okay, so at this point we're going to solve equations that involve expanding brackets. So what do we mean by expanding brackets? What it means is we multiply the term that's outside the brackets by first term inside the brackets, so 5 times a, and then we multiply the term that's outside the brackets by the term inside, so we multiply the 5 times 3. After we do that, we're going to see that this question becomes just like the two-step equations that we saw before. So we solve it by expansion, and then we solve it as a two-step equation. So first let's look at expanding it. So 5 times a, we write that down, 5 times a, and then we write plus, because there's a plus sign in the brackets. And then we do 5 times 3, and we write that down, equals 30. All right, so what is 5 times a? That's 5a. 5 times 3 is 15. So now we have a two-step equation, just like the ones we had before. So again, we get rid of the number being added to the variable term, so we subtract 15 from both sides. We're going to end up with 5a on the left, 15 on the right, and then we're going to divide both sides by 5, and we end up with a equals 3. So again, remember, first of all, expand the brackets, and you'll get this, which is a two-step equation. Then just solve, just like we did with the other two-step equations. Okay, so again, we've got another equation that involves expanding. And so what are we going to do again to get rid of those brackets? What do we mean by expanding? That's question A. And what do we do after getting rid of the brackets? And what kind of equation are we going to be left with? Okay, so again, when we expand, we have 4 times b plus 4 times minus 2. And that gives us 4b minus 8 equals 24. And C question here says, what kind of equation do we have now? This is a 2-step equation. And so again, we just solve it like any 2-step equation. I won't even go into all the detail because we've been doing a lot of those. We end up with b equals 8. Okay, what do we have here? Well, we talked earlier in the course about how we can model an equation using a diagram. So this is like a picture that stands for an equation. And so what equation would it stand for if every box stood for an x and every circle stood for a number like 1? Well, we would have x plus 3 on the left side. You can see that right here. We would have 5 on the right side. So x plus 3 equals 5 would be the equation that is represented by this diagram. Alright, so here's one to try. Try this in your head right now. What do you think the equation would be for this diagram? Well, the box would be x. Then we have 2 on the left. So x plus 2 equals 6 on the right. So there's our equation. All right. So we got something here that stands for a lot of brain power. We're going to use an equation to solve a word problem now. So the question says, Alex says to Callie, I'm thinking of a number. If you divide my number by 8 and then subtract 12, the result is 14. It's kind of like one of these, I'm a mind reader sort of question. So it says, write and solve an equation to determine Alex's number. So first of all, if we're going to come up with an equation, what variable would you choose to represent the number? Because Alex is thinking of some number. So what variable would you choose? Next, show the math operation, the next math operation in the equation. So if we read the question, it says, I'm thinking of a number. If you divide my number by 8, okay, so use the variable that you've come up with, and then what would you use to represent my number divided by 8? How would you show that in math? Okay, the next one, C, says, next, show the next math operation. So next you're subtracting 12. And then the last part says, now show the result is 14. So we're going to take all these math words and kind of translate them into math symbols. Okay, so let's do that one step at a time. What variable would you choose to represent the number that you're guessing here? Let's choose n. N stands for number, right? Why not? Okay, B says, next, show the next math operation in the equation. Okay, so the next part of the question says, if you divide my number by 8, so since the number is n, you would have n divided by 8. So that's what we've got so far for our equation. And then we read the next part. It says, then subtract 12. So we had n over 8, and now we're going to have n over 8 minus 12. And the last part, when we read the question, it says the result is 14. So, in other words, n over 8 minus 12 equals 14. That's what it means by the result is 14. That math that you do is going to equal 14. So now we've got a 2-step equation, and we just have to solve it like any 2-step equation process that we looked at before. Okay, so again, I won't really go into this part. You can look at it later if you want to review and check your answer. But we're just solving this like any 2-step equation. and we end up with n equals 208. And just as a reminder of what we were doing some math and finding the result is 14. And so we were looking for his number that he started with. So in other words, he started with 208, he did some math, and after he did some dividing and subtracting, he came up with 14. Okay, so now we're going to look at a question that has to do with bank teller. My kids are in elementary school, and this year they've been having ATB Bank coming in, and so my kids are kind of running a bank in their school, and so my daughter's had a chance to be a cashier, and my son has had a chance to be like he counts the money. Can't remember what his job is called. But anyways, they were actually on TV a few months ago, and that was kind of cool. So the question here says, Jill has $36 in the bank. She deposits the same amount of money each week. 3 weeks later, she has $162. How much money did she deposit each week? So what we need to do is to create an equation to represent the situation. Then we need to solve the equation to find out how much she deposits every week. Okay, so how are we going to come up with this equation? Well, it says that the total amount she has after 3 weeks is $162. So total amount after 3 weeks is equal to the $36 she started with plus the amount that she deposited after 3 weeks. So total amount equals 36 plus 3 times, since there's 3 weeks, whatever amount she deposited each week. That's what X is going to be. So that's our equation. Total amount equals $36 plus 3 times X, where X is the weekly amount deposited. So we multiply 3 times the amount she deposits each week because there's 3 weeks she's depositing. So now we take that amount, or sorry, I should say we take this equation and we're going to plug in the amounts we know. We know the total amount after 3 weeks is 162, so we say 162 equals 36 plus 3x. That's our equation, and that we need to solve like a two-step equation. You can see we're going to subtract 36 from both sides, then we're going to end up with dividing by 3 to get rid of the 3 and 3x, and we end up with x equals 42. That's the amount she deposits every week. And again, you can plug this into your equation and check and see if you've got the right answer. Right on. Okay, we've got another question. It says, Jasper put together a set of gears in science class. The circumference of the green gear is 24 centimeters. Remember, circumference is the distance around the edge of the circle. The circumference of the black gear is 4 centimeters more than 1/3 of the green gear. The circumference of the blue gear is half of the black gear. And I underlined what it's asking for. It says, determine the circumference of the black gear and the blue gear. Okay, so if we're going to solve this like an equation, we can call the green gear G, the black one BK, and the blue one BU. Now we're going to write an expression using the info that we're given in the question. So we know the circumference is 24, and we know this info, and then we're going to put together all the expressions we come up with and make an equation that we solve. Okay, so we're told that the circumference of the green gear is 24, so I just wrote G equals 24. In another place in the question, we're told the circumference of the black gear is 4 centimeters more than 1/3 of the green gear. So 1/3 of the green gear would be 1/3 G. It's 4 centimeters more, so we write plus 4. Doesn't matter if we write the plus 4 at the beginning or after the G part. So black equals 4 plus 1/3 G. There's also some info that says the circumference of the blue gear is half of the black gear. So blue gear, BU, equals 1/2 black gear. Now we're going to put together all these facts and we're going to solve for BU and BK, blue and black. Okay, so here's all the info we came up with, all the kind of little mini equations we came up with. And we're going to use them together to solve for BU and BK. Okay, what you always want to do is find two equations that include the same variable in them. See, here's G equals 24, and here's BK equals 4 plus 1/3 G. So if BK is equal to, okay, here I wrote them, G equals 24 and BK equals 4 plus 1/3 G. So where we see G, we can just plug in 24 since we know G equals 24. So instead of saying this here, we say BK equals 4 plus 1/3 times 24. And so now we do the math. 4 plus 1/3 of 24, that's going to be 4 plus 8. 4 plus 8 is 12. So BK equals 12. So we know that the black here is 12. We've already solved for the black here. Now we need to find out what BU is, which is the blue here. So another thing we had up above here was BU equals 1/2 of the black here. So we just find out what 1/2 of 12 is, and that's going to be 6. So we're kind of coming up with mini equations to solve for BU and BK. And that's only one way you could have solved that question. We're going to see in the next question that you can solve it using two different methods. So it says the students in Mr. Hagel's math class are trying to guess his age. He tells them that his daughter is 4 years younger than 1/3 of his age. When asked about his daughter, he tells the class that she's 2 years older than half of Meg's age. And Meg is a student in the class, and she is 14. So how old is Mr. Hagel? So first I'm going to show you how you could solve this using math reasoning, and then using the math equation. So using math reasoning, here's the info that we're given as in part of the question. Part of the question says that Meg is 14 and that his daughter is 2 years older than half of Meg's age. So half of Meg's age is 7, and 2 years older than that would be 9. So Mr. Hagel's daughter is 9. Okay, so we know that much so far. His daughter is 9. And then it says that his daughter is 4 years younger than 1/3 of his age. Now, if she's 4 years younger than 1/3 of his age, if she was 4 years older, she would be 1/3 of his age. So, since her age is 9, if she was 4 years older than this, 9 plus 4 would be 13. If she was 4 years older, then she would be 1/3 of his age. So if she was 13, she would be 1/3 of his age. In other words, 13 is 1/3 of his age. So 13 is 1/3 of what number? Well, it turns out that's 39. And all you need to do to find that is to multiply 13 by 3. So Mr. Hagel is 39. And we figured that out using math reasoning, just kind of using little bits of the info given in the question at a time. Now let's look at how we use an equation to solve it. So first of all, we want to define each one of the variables for each one of the people we have. So we say, let D stand for the daughter's age, H stand for Mr. Hagel's age, M stand for Megan's age, which we're told is 14. So then we're given some info in the question. Daughter is 2 years older than half of Megan's age. So we can translate that into math, and we can say D equals 2 plus 1/2 M. Now we know that M is 14, so we say D equals 2 plus 1/2 of 14. D equals 2 plus 7. D equals 9. Okay, so we know that the daughter is 9. Now we use the rest of the info. So this black info here, bold info, is right from the question itself. Daughter is 4 years younger than 1/3 Mr. Hagel's age. So D equals 1/3 H minus 4. Since she's 4 years younger than 1/3 of his age. So we have an equation here, D equals 1/3 H minus 4, and we need to solve for h, because we're trying to find Mr. Hagel's age. And we know that d is 9. We already found that. So now we have the equation 9 equals 1/3 h minus 4. And we're going to solve for h. So when we solve for h, we have a third in the equation. And to get rid of the 3 and a third, we're going to multiply by 3. It's just like we saw earlier on. When we have division, dividing by 3, we do the opposite of dividing by 3, which is times 3. So we multiply everything that's in the brackets by 3. So this is what we had before. We had 1/3 h minus 3. And we put it in brackets to show that we're going to multiply everything there by 3. Not just the 1/3 h. Everything on that side of the equation. And same thing with the left side. When we multiply 3 times 9 on the left side, we get 27. And then let's figure out how we multiply here. We multiply the 3 times the 3 in 1/3, and that leaves us with just h. And then we're going to multiply the 3 by the minus 4 that's in the brackets. 3 times minus 4 is minus 12. So we're left with h minus 12 on the right side of the equation. So now we have this equation, and again, we can solve that like a two-step equation. Actually, it's a one-step equation at this point. And we get 39 equals h. So again, we use an equation as well as math reasoning to solve this question. And you can choose which one you prefer. But either one, when you're showing it on the test, you need to show the math that you're doing. Okay, question 12 says, properly describe the points in the graph. So we're moving away from equations right now, and we're talking about things like points on a graph. So we're not going to look at all the points in the graph, but if we were looking at this one here, how would you tell what this point is? How would you describe this point? It says describe it in the point blank comma blank. Well, we always put x value and then y value when we're describing a point, right? So when we look at this point, we look at the x value, that's this one, which is 2. Then we look at the y value, which is 6. So this would be 2, 6. That's what A would be. How about B? Well, again, we look at the x value first, which is 3, and the y value, which is also 3. So we saw that A was 2 for the x value, 6 for the y, and B, both x and y, had 3. Okay, so you can try these other ones, C, D, and E, and see if you can describe what the x and y values are. Okay, now we're going to talk about creating a table of values. So what is a table of values again? A table of values is a table that lists the pairs of values. In other words, the x and y values, or you could say input values and output values. So for an equation like this, one of the variables is the input value and the other is the output value. So to create a table of values for the math equation y equals 3x, we're going to put the x on the one side and the y on the other side. Now because y is equal to 3x, I put in brackets 3x beside y. So now what I need to do is I choose values for x. Usually it's easiest to choose values like 1, 2, 3, 4. And then I plug those x values into the equation. So I plug 1 for x into the equation, and I see what I get for y. So because y is equal to 3 times x, since x is 1, it's 3 times 1, which is 3. So y is going to be 3. So again, looking at our equation here, we said x was 1, so it's like 3 times 1 is 3, so y equals 3. Same thing when y equals 2, x is going to be 2, same thing when x is 2, it's going to be 3 times 2, and then y is going to equal 6. And you can see the math here. Let's see, we do the same thing with 3 and 4 as well. So this is the table of values. So the actual values are going to be x is 1, y is 3, x is 2, y is 6, and so on. Those are the actual values in your table of values. Okay, now I'd like you to try one like this. It's a little more complicated, and it's for the math expression C equals 4 times n plus 3. And so to make the table of values, you put the one variable n and the other variable c, and because c equals 4 times n minus 3, I put it beside the c. Okay, so again, for the n values, we'll choose 1 to 4, and we write out here 4 times 1 plus 3. So what is 4 times 1 plus 3? Well, 1 plus 3 is 4. 4 times 4 should be 16, shouldn't be 15. Okay, then we go on to the next one. When n is 2, it's going to be 2 plus 3. 2 plus 3 is 5. We multiply that by 4, gives us 20. Okay, so that's how you do it. You just take this expression, plug in n, and see what you get for c. Okay, parlez-vous français? We're talking about language translation here. I don't know if you guys speak French or if you sprachen Sie Deutsch, like German. Anyways, we're going to practice kind of being a language translator here. And so what we're going to actually do is translate from English words to math symbols. So for example, if you have an English statement like k is equal to half of n added to 4 times n, we translate each one of those words. And you can see that below the k, I just wrote k. Where it says is equal to, I wrote the equal symbol. Half of n, I wrote 1/2 n. Added to, I wrote plus. 4 times n, I wrote 4n. So this is the math equation. K equals 1/2 n plus 4n. All right, so now it's your chance to try one. And what I want you to do is to write the math equation that goes with the English statement below. So t is equal to 5 times the sum of 4 and n. Okay, so what you would say, or says t is equal to, you would write t equals 5 times a certain amount. A sum is two things that are being added together. So you're adding together 4 and n. So you're going to have 5 times 4 plus n, and you're going to put that in brackets. Okay? 5 times two things being added together. That's what sum means. So 5 times 4 plus n. T equals 5 times 4 plus n. Okay? So we'll look at the next one. It says, figure out the cost, we call C, to rent a car for T days at $27 per day if you have a coupon for $15 off the total cost. Okay, so since we need to write an equation for cost, we're going to say C equals something. Okay, well it's going to be T days. T stands for the number of days. It's $27 per day. So we're going to multiply 27 times t. This is 27 times the number of days, and t stands for the number of days. So far our equation is c equals 27 times t. Now we have a coupon for $15 off the total cost. So far our equation gives us the total cost, but we're going to have $15 off, so we're going to say minus 15. That didn't come out quite right. The minus 15 should be down below, but c equals 27t minus 15. That should be our equation. All right. So the next one says, Sierra is planning a party. The food will cost $8 per guest, and the cake will cost $24. Part A says, write an equation someone could use to figure out the cost of the party for any number of guests. Then it says to create a table of values to show the cost of the party for 4 to 8 guests. Okay, so first of all the question is, what equation are we going to use? And then, what table of values are we going to come up with? So we'll look on the next page. Okay, so we're told that the food costs $8 per guest and the cake will cost $24. So it's going to be the cost of the cake plus $8 times the number of guests. So C equals 24 plus 8 times G, 8 times the number of guests. So to make our table of values, we're going to take each variable, C and G, and we usually put the one that's, you know, like Y equals whatever or C equals whatever. We usually put that on the right side of the table of values. And the one that's found in the equation, we put on the left side. Okay, so we're going to put the G on the left side, and we're going to put C on the right side. And what does C equal? Well, it's 24 plus 8G. So we put that in brackets. Okay, so the question said that we're going to use it for between 4 to 8 people. So we don't put like 1, 2, 3, 4 like we did before. We don't just choose numbers for G because the question actually tells us what G should equal. That it equals between 4 and 8 people. So we put 4 to 8. Then we plug the number 4 into our equation, 24 plus 8 times G. So that's 24 plus 8 times 4, 24 plus 32, that gives us $56. We do the same thing to calculate the C value for each of the other numbers. So again, each one of these G values matches with the C values that you get when you plug it into the equation. And that's our actual table of values. These numbers here, 4 and 56, 5 and 64, etc., those are our actual numbers in the table of values. Because what is a table of values? It's a pair of input values and output values. For instance, X and Y values. That's what a table of values is. All right. So, got a picture of a fairground here. Kind of reminds me, my kids are going tonight. I'm going to go with them to Galaxyland, go on some rides. They've got it half price on Wednesday. They call it Wacky Wednesday. So my kids are totally looking forward to that. I don't know how many of you guys have gone to Galaxyland, but my kids totally love it. So should be a fun time. All right, the question here says Trina is going to the fair. Admission to the fairgrounds is $15 and the rides are $5 each. If Trina has $75 to spend on rides and admission, how many rides can she go on? So, I wrote some questions here to think about. What do we need to create in order to solve this equation, this question? Well, basically we need to solve some sort of equation, or at least that's one way of doing it. And then what do we do next? Okay, so I wrote here, what do we need to create in order to solve it? We can create an equation. Once we create the equation, we can use the info we're given, the fact that she has $75. We plug that 75 into the equation, and we're going to solve for what we're trying to find, how many rides she can go on. So let's see what that looks like. Well, the total cost, we're told, is $15 admission plus $5 per ride. So cost equals 15 plus 5R. That's our equation. We're going to put in the 75 we know, that's the total cost, and we're going to find out what R is, how many rides she goes on. Okay, so we take our equation, we plug in 75 for C. So at this point we have this equation, and that's a two-step equation, so we solve that like any two-step equation. First of all, we need to get rid of the 15, so we subtract 15 from both sides. We now have 60 equals 5R. What do we do to get rid of that 5 that's with the R? We're going to divide both sides by 5. When we do that, we end up with 12 equals R, so she can go on 12 rides in all. All right, awesome guys. We're finished watching this recording, and I want to encourage you guys to practice all the purple questions. If you guys do that, I can guarantee you will do well on the test. If you find there's questions you don't know how to do, you need to ask and make sure you can get some help so you can get all the questions, all the purple questions when you're practicing, and then you should be able to do very, very well on the test. So I want to encourage you guys to practice all those questions over and over again until you can get them really well, really easily. Again, the test is on April the 19th. I want to wish you guys the best. Keep working really hard, guys. We're getting close to the end of the year. It's really important to keep your focus till the end of the year. Just like the teams that are in the NHL playoffs right now, you know, they made it to the playoffs, but they have to keep working really hard so they do well in the playoffs as well to win the Stanley Cup. So thanks for your hard work, guys. Have an awesome day. God bless. Bye for now.